In this video, I'm going to discuss how to evaluate integrals of this form, where the powers of sine x and cosine x are non-negative integers. Let's get started. Let us first consider the case where m or n is a positive odd integer. So this case can be divided into two sub-cases. So for example, the case wherein m is odd, so that is the power of sine x is odd. And the trick in evaluating this integral, if the power of sine x is odd, is to just pull out one sine x, okay? One sine x, and express the remaining factor of the integrand in terms of what? Sum of powers of cosine x. And we can do this because when we factor out sine x from sine raised to m of x, then the remaining power of sine x will be even power. So we can use this identity sine squared x equal to 1 minus cosine squared x to express this factor here in terms of cosine x. And we can just multiply it by cosine raised to n of x. So therefore, this factor here of the integrand can be expressed as sum of powers of cosine x. And after writing it as a sum of powers of cosine x, we can now use u substitution. So we let cosine x to be our u. And if this is our u, our du is just negative sine x dx. So that means this factor here, sine x dx, can be written as negative du. And what we'll get here is just what? An integral of a polynomial of u, du. So it's very easy to integrate. Now, if we look at the other case where the power of cosine x is odd, so we do similar thing here. So we factor out one factor of cosine x, and this remaining factor here can be written as sum of powers of sine x. And again, we use u substitution afterwards. So if we let this sine x to be our du is cosine x dx. And this integral here, in terms of u, is just an integral of a polynomial in u. So therefore, it's very easy to integrate. Let's show some examples. So let's evaluate integral of sine raised to 4x cosine raised to 5x dx. So since the power of cosine x is odd, so what we're going to do here is to factor out cosine x and write the remaining factor of the integrand in terms of sine x. So here we do something like this. We factor out this cosine x, and the remaining factor of this cosine raised to 5x will be cosine raised to 4x. And since this is an even power of cosine x, we can use the identity cosine squared x equal to 1 minus sine squared x. So this cosine raised to 4x here is equal to the square of sine 1 minus sine squared x. This product here is can be written already as sum of powers of sine x. Actually, you don't have to write it first as sum of powers of sine x before you do u substitution. As long as you have factored cosine x and have written the remaining factor in terms of sine x, you can already do u substitution. So in this case, if you let u be equal to sine x, then we can replace this now in terms of u. So you'll get u raised to 4 times the quantity 1 minus u squared, quantity squared, and then this cosine x dx is replaced by du. Now, to evaluate this integral in terms of u, what we're going to do is to do some algebraic manipulation first. So we do expansion, and then we distribute u raised to 4. Okay, take the product of these two polynomials, and we'll get u raised to 4 minus 2u raised to 6 plus u raised to 8 du. This is just a polynomial, so it's very easy to integrate. Just use ordinary power rule. You'll get 1 over 5 u raised to 5 minus 2 over 7 u raised to 7. plus 1 over 9 u raised to 9 plus c. And then don't forget to put back the u in terms of x since you're integrating with respect to x. So since u is equal to sine x, our final answer will be this expression. Let's try one more problem. So let's evaluate integral of sine raised to 5x dx. So the power of sine x is add. So again, we pull out one sine x and write the remaining factor sine raised to 4x in terms of cosine x. So again, the power of sine x here is even. We can use 1 minus cosine squared x for sine squared x. So we can write this factor here as the square of 1 minus cosine squared x. So now we can already use u substitution here. You let cosine x to be your u, and our du here will be negative sine x dx. So this sine x dx is equal to negative du. So you'll get here negative du for your sine x dx. And we already have here just a polynomial in use, so we expand before we evaluate the integral. So we'll get here 1 minus 2u squared plus u raised to 4. We distribute the negative sign and integrate each term. So we'll get negative u plus 2/3 u cubed. So this is just using ordinary power rule, and then minus 1 over 5 u raised to 5 plus c. So when you apply power rule, just add 1 to the power divided by the new power. So you'll get here u raised to 3 over 3 for the integral of u squared. And again, don't forget to put back your u in terms of x. So u is equal to cosine x. So using this substitution equation, you'll get negative cosine x plus 2/3 cosine cube x minus 1 over 5 cosine raised to 5 of x plus c. Now let us consider the case where m and n are both non-negative even integers. For this case, the strategy is to use the following identities. These trigonometric identities came from double angle identities. Let's have some examples. Let's say we want to evaluate integral of sine squared x dx. So for this integral, we use this second identity. And we can write our integral into this form. Of course, it's very easy to find an antiderivative of 1/2. So this integral of this difference is equal to difference of integrals. Now, to evaluate integral of 1/2 cosine 2x, we use u substitution. So if our u is equal to 2x, then our du will be 2 dx. Now, the original integral here is integral of 1/2 cosine 2x. So to make this integral equal to integral of 1/2 cosine 2x, so we need to multiply 1/4. So 1/4 times 2 is equal to 1/2. So this is now in the form integral of cosine u du. So the value of this integral is sine u. Sine of u is equal to 2x. So therefore, the integral is equal to 1/2 x minus 1/4 sine 2x plus c. Next is integral of cosine raised to 4x dx. So in this case, we use the third uh, identity, and we can write this one as the square of cosine squared x. So that is square of 1 plus cosine 2x all over 2. And again, so we just expand this expression. We'll get 1 over 4. The square of the denominator is 4. So that is 1 over 4 times the square of the numerator, which is equal to this one, 1 plus 2 cosine 2x plus cosine squared 2x. And this is equal to the sum of these three integrals. So we have here 1/4 integral of dx plus 1/2 integral of cosine x dx, because 2 times 1/4 is equal to 1/2. And then we have here 1 over 4 times 1 plus cosine 4x all over 8. Why is it all over 8? So we used again this identity here, but our x here is this 2x. So we can use this identity. So the cosine squared of 2x is equal to 1 plus cosine 4x all over 2. And you multiply that with 1/4. So that's the reason we have here 1 over 8. So now we can evaluate this integral already. This is equal to 1 over 4x. And then plus, this is integral of cosine u. Okay, our u is 2x. Our du must be what? Okay, 2 times dx. We don't have here 2, so we have to multiply this by 2 and divide by 2. That's the reason we have here 1/4. So 1/4 times sine u, okay, or sine 2x. And then plus integral of 1 is just equal to 1 over 8x. And again, use u substitution to evaluate this 1 over 8 integral of cosine of 4x dx. And again, if your u is equal to 4x, your du is 4 times dx. Okay, so if you produce the du, you have to divide again by 4. So this 1 over 8 here becomes 1 over 32. So therefore, this integral of cosine 1 over 8 times integral of cosine 4x dx is equal to 1 over 32 sine of 4x. And of course, plus the arbitrary constant c. So we just combine these two like terms here and we'll get 3 over 8x plus 1/4 sine 2x plus 1 over 32 sine of 4x and then plus c. Let's have another integral. Let's evaluate integral of sine squared x cosine squared x dx. So in the case where the powers of sine x and cosine x are equal, so the first step is to factor out the power. So in this case, we factor out the 2. We can write it as square of sine x and cosine x. And now we use identity for this sine x cosine x. So this is just equal to 1/2 sine 2x. Now we can already distribute these 2 here and we can write our expression as 1 over 4 sine squared 2x. And here we can use the identity sine squared of theta equal to 1 minus cosine of 2 theta all over 2. So therefore, we can write this sine squared 2x here as 1 minus cosine 4x all over 2. So that becomes 1 over 4 times 1/2. So that is equal to 1 over 8. Our theta here is equal to 2x. And now integral of 1 is just equal to x and then antiderivative of cosine 4x. So to evaluate integral of cosine 4x dx, you use again u substitution. So to produce the du, your du is 4 times dx. So you'll get here 1 over 32. It's like dividing this 1 over 8 by 4. You'll get 1 over 32 and then sine of u. So your u is equal to 4x and then plus the arbitrary constant c. Now let us discuss another strategy in evaluating integrals of powers of sine x or powers of cosine x when n is greater than or equal to 2. So here we're going to use what we call reduction formulas. So these reduction formulas can be obtained using integration by parts. It's not that hard to remember these formulas because if you ignore this negative sign here, you only have here 1 over n and then n minus 1 all over n. So the sum is equal to 1. this 1 over n, and then plus n minus 1 all over n. And then as you can see, the powers, it is n minus 1, and then n minus 2, n, n minus 1, and then n minus 2. Now, why do we have a negative sign here? Because when you use integration by parts, your dv here is actually sine x dx. So if your dv is equal to sine x dx, this is actually your u, okay? And your dv is, your v will be negative cosine x. So v is the integral of dv. In this case, the dv is cosine x dx. So when you integrate the dv, you'll get just sine x. So you know here that you have a negative sign because your dv is sine x dx, and the integral of that is equal to negative cosine x. So that's how you remember this reduction formulas. Because for me, it's easier to use reduction formulas than the method that we used in case 2, in case this n here is even and it is greater than or equal to 4. Let's look at some examples. Let's say we want to evaluate this one. We already evaluated this, okay, in the previous case, but let's try using reduction formulas. When we use reduction formulas, as you can see, after using this once, using the second formula once, we'll get already 1 over 4, and the power is reduced, okay, decreased by 2. So from integral of cosine raised to 4x, the new integrand now is cosine squared x. That's why we call it reduction formula. It reduces the power of the original integrand. And again, to evaluate this one, we can use this reduction formula again. So our n here is equal to 2. So using this reduction formula, we'll get 1 over 2. Okay, cosine raised to 2 minus 1 is 1. So cosine of x sine x plus 1 half integral of dx. Okay, because 2 minus 2 is equal to 0. So this becomes 1. So 2 minus 1 over 2 is just 1 half. And we can easily evaluate this one. So as you can see, if you know your reduction formulas, you can easily evaluate this, okay, which is equal to this one. Although this looks like a different expression, okay, compared to the one that we obtained a while ago, but we can show that this expression here and the antiderivative that we found a while ago differ only by a constant. They may be equal, they may differ by 1, by 2, by 3, negative 3, and so on. As bonus to this video, let us consider also integrals of this form. So m is not necessarily equal to n. So if m is equal to n, we may use the strategy in case 2 or case 3. So what if m is not equal to n? In this case, if m is not equal to n, we use the following product identities for sine and cosine. So we can actually obtain these product identities, product to sum identities, from the following sum and difference identities for sine and cosine. So if you don't know these identities, just derive them from the following sum and difference identities for sine and cosine. For example, to obtain this first identity here, just add these two equations. Okay, so if you add these two equations, you'll get rid of this term and then this term. So the right hand side of the sum will be 2 sine A cosine B. And you divide both sides by 2, you'll get an identity for sine A cosine B, which is equal to this expression. So let's try some problems. Let's evaluate integral of sine 7x cosine 3x dx. So we use the product identity for sine and cosine to evaluate this one. So that is sine A cosine B is equal to 1/2 of sine of A minus B plus sine of A plus B. So our A is 7x and our B is 3x. So this becomes 1/2 sine of 7 minus 3x, which is 4x, and then 7x plus 3x, which is equal to 10x. And what is an antiderivative of sine 4x? It is equal to negative cosine of 4x all over 4. So that is 1/4 times 1/2, you'll get this 1 over 8. And antiderivative of sine 10x is negative cosine 10x all over 10. And multiply it by 1/2, you'll get negative 1 over 20 cosine 10x. And then plus the arbitrary constant c. Now let's have one more problem. So integral of sine of 8x sine 2x dx. So here we need to use the product identity for sine A and sine B. So we'll use sine A sine B equal to 1/2 of this difference, cosine of A minus B minus cosine of A plus B. So we'll get here cosine of 8x minus 2x, so that is 6x minus cosine of 8x plus 2x, which is equal to 10x. And what is an antiderivative of cosine 6x? It is sine 6x all over 6, and then times 1/2. So you'll get 1 over 12 sine of 6x. Antiderivative of cosine 10x is sine of 10x all over 10. So that gives you, and then you have the minus sign here, and then times 1/2, you'll get negative 1 over 20 sine of 10x, and then plus c. Last problem. So if we have here integral of cosine 4x cosine 6x dx, so we use the product identity for cosine A cosine B. So that is cosine A cosine B is 1/2 of this sum. Okay, so using this one, a minus b, 4x minus 6x is negative 2x, and then a plus b, so you have 4x plus 6x equal to 10x. Now, since cosine is an even function, so cosine of negative 2x is the same thing as cosine of 2x. And now we find the antiderivative of each. Antiderivative of cosine 2x is sine 2x over 2 times 1/2. So you'll have here 1/4. Antiderivative of cosine 10x is sine of 10x all over 10. And then times 1/2 again, you'll get 1 over 20. And then plus c.